All right, good morning, Math 103ers, or good afternoon, whatever time you're watching this video. I hope you guys are doing good, and I hope you can understand. Just a reminder, whenever you watch a video, you can always pause or play it at a faster speed or a slower speed to help you understand what's going on. We left off class the other day looking at this last challenge problem. There are two things here that are causing our domain to be limited. So remember, the denominator is what we don't want to be what? If we're causing something to be limited, we don't want it to be 0. Okay, so we look first at our denominator here, and we have the hint right here on the side saying that denominator is x plus 9 times x minus 1. Now, if you guys could factor that, that is great. Now, if you guys cannot, then just try to see why. And the way that we factor is what multiplies and adds. And those are your two numbers here. What multiplies to give you negative 9 and adds to be 8. So we are saying that this denominator cannot be 0. Okay. And those two places are where it makes my denominator 0. So this is called the zero product property again. If I'm multiplying two values, one of them is 0, then the whole equation becomes 0. So what do I need in here that will make that 0? Is a negative 9. How about in here? That would be a positive 1. So what we're going to say here is x cannot be negative 9 or 1. Okay, so if we throw that on a number line, yeah, where is that going to be? So we got negative 9 on this side and then a 1 over here. We're going to put circles right there. All right? It's everything but those values. Now, are we done? Not quite, because we see a radical. Do you guys remember what the radical does to my equation? If I have a radical right in there, remember we cannot have certain square roots. Yeah, we can't square root negatives. So inside the radical, in this case, it's a pretty easy one in the sense where I don't have that x. I think it was 5 minus x on the previous example. We just have x inside the radical, and that has to be positive, okay, or 0. It can be 0 as well. So I'm going to mark that here as well. There's a 0, and it can be 0. So I'm going to color it in, and then I'm going to shade the part that's true. So it's all of these values to the right, okay. None of the values to the left of 0 work, including negative 9, okay? In this equation, or in this function, I have the radical that's limiting my 0 and positive, and then I have pukas on the bottom because I cannot have negative 9 and 1. Okay, so now we're going to put this all together and list the new domain. The new domain is going to be whatever I've shaded, okay? Meaning from here to here, and that's it. Now, I do have a puka at 1, and do I even have to worry about this side? No need, okay? Because that doesn't exist anymore because of the radical, okay? So I'm going to start at 0, include it. I'm going to go to 1, and then I'm going to go from 1 to infinity. And that is my domain. Okay, on this side is positive infinity. All right, hopefully that makes sense. Now, on the next page, you have a little bit of summary for functions. So for functions, I want you guys to go read through this. Some things that you want to remember is input, independent variable or argument is x, and it doesn't mean times. Okay? And f of x is the output, the dependent variable, or the function value. And function notation is actually better. It's a more descriptive and efficient way to communicate what's going in and then what's coming out. So for example, f of 3 equals 25 says that the input is 3, the output's going to be 25, and then we have what is called coordinate points. So what are the coordinate points here for f of 3 equals 25? That would be the point 325. And that point lies on the graph of f of x. Okay, so just some things that we want to get more familiar with. Now, if you look at the next page, let's go down to page 22. You have a domain practice. So I want you to go and work on numbers 1, 2, and 3. Hit pause and then hit play in a second. And I will go over this once you try. Okay, so hit pause and then try it. All right, so if you guys hit pause and you tried it, then let's go over it. So on number 1, I see that we have a fraction and I have denominators that have x. So notice they kind of helped you out with factoring the denominator out. And we say that x times x minus 7 cannot be 0. That's what you want to say there. And this is a zero product property. You see I have x times another factor. So this cannot be 0 and this cannot be, or yeah. So tell me where they are 0. Okay, so x here is 0 at 0, and then x minus 7, what makes that 0? That has to be 7, so you'd say x cannot equal 7. So you have 2 places where x cannot be at 0 and at 7. So I'm going to put pukas right there, and I don't have any more radicals or anything else, so this is right here, my domain, right here, here, and here. So what's on this far left side is negative infinity to positive infinity. And let's now list our domain. So the domain, start from the left and kind of just go to the right. I'm going to have a union right here and here. So negative infinity to 0, union 0 to 7, and 7 to infinity. No brackets on any of that, just parentheses. Yeah, that one kind of looks like a bracket. So fix that. Number 2, excuse me. Number 2 has a radical. We have a cube root as well, but the cube root is okay. Anytime you have an even root is where you can't have negatives. So this is the one we got to focus on. Inside that square root, not inside the cube root. Okay? So we don't have to worry about the other ones. There's no need to worry. So we have now x plus 4 has to be what kinds of values? It cannot be negative, so it has to be greater than or equal to 0. And if you, in your mind, you're like, okay, what values make that greater than or equal to 0? Well, negative 4 is the place where it starts, yeah, because that would make it equal to 0. Negative 3 would now make it positive. So if you want to do the algebra behind it, you could subtract 4 to both sides. And now you're left with x is greater than or equal to negative 4. So this is your domain. If you were to draw it, you have negative 4 here. Oops, sorry, negative 5 here. And then you would say, okay, at negative 4, I can be, and where else? All the values that are greater than that. Okay, so if I'm going to list my new domain, it's going to start at negative 4 and go to infinity. Okay. Both of these are good. These are both good ways to show the new domain. Okay, moving on to number 3. I have a fraction and I have an even root, but the even root's in my denominator, something new and different here. We want to say that that's where we have 2 things. The denominator cannot be 0 and the radical cannot be negative. Okay? So 9 minus x has to be positive. Sorry, greater than or equal to 0. But it cannot be 0. Okay? So that's where we also say this. This right here cannot be 0. So I take away the equal to. You guys see that? I cannot be 0 because, why? I cannot divide by 0. So the denominator cannot equal 0, and because of the radical, has to be positive. Now at this point, I can do a little bit of algebra, just add x to both sides. I get 9 is greater than or equal to x. Oh, the 8 kind of appeared there. I think I hit 8 on my keyboard. Sorry about that. So 9 is greater than x. Now, if I were to Let's see if I can delete that. Yeah, there we go. If I were to graph that, what does that look like? It's a little bit different because my x is on this side. So when you read from where your x is. So x are all the values that are smaller than 9. So here's 9. What are the values that are smaller than 9? I'm going to put an open circle right at 9 and then shade all the values to the left. Okay, so my domain on this side is negative infinity. And we don't want to include 9. Remember again, 9 is included if it's just a radical in our numerator because we can have 0. We can square root 0, or in this case, 4th root. But we cannot have 0 in our denominator because we cannot divide by 0. Okay? Hope this practice helps. And we're going to move on to the next section on solving linear inequalities. So I will post the next video in a minute.